Hi everybody. So this is attempt number 3 at this video, actually attempt number 4. So if the p-value is 0.0625, will the 95% confidence interval contain the proposed population proportion, which is 0.5 in our example. So I'm going to walk around on the board. My apologies if I make you nauseous by moving. Here we go. So our null and our alternative are going to be this. We're looking at it as a two-tailed test. So that means the p-value will get split, and I'll show you what's going on there in a minute. So the first thing that we're going to do is we're going to generate every possible sample of size 5. So our n is going to be 5. And I did this to try and give you an idea what a total sampling distribution would look like. So we're going to talk about zeros as being our failures and 1 being our successes. So the probability of a 0 is 0.5, the probability of a 1 is 0.5. So our center is going to be 0.5. And we are testing the null hypothesis that pi is going to be equal to 0.5. And the alternative hypothesis is that it's not equal to 0.5. So again, two-tailed test, and we'll end up splitting our p-value. Okay. Now, this is every possible sample of size 5. So you could have failure, 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 failure. So 0 successes out of your 5. Now notice there's only 1 of those. Extremes tend to happen very rarely, okay? And what I mean by extremes is far away from the middle. Okay, so over here is our 5 out of 5. And if you track down the paths, you see you get a 4 out of 5, so 4 successes out of 5, 4 successes out of 5, and then you have 3 successes out of 5, 4 out of 5, and on down. Now, taking all of those possible samples, each of those is a p-hat. Now we're going to put a dot plot up, and we're going to have all 32 possible samples. So the p-hat of 0, 0 out of 5 successes, only occurs once. The p-hat of 1, 5 out of 5, only occurs once. You get 5, you get 10, you get 10, you get 5. Even when your sample size is 5 and you generate every possible sample that occurs, you still end up with something that's reasonably symmetric. Okay. Now, we're dealing with a two-tailed test, so I have to think about p-value as both sides. So we're going to talk about 5 out of 5 and 0 out of 5 as the same distance from the middle. And so the p-value of 5 out of 5 is 1 out of 32, because there's here or more extreme, and the p-value of 0 is 1 or more extreme, because there's 1 dot there. Well, that's a total of 2 out of 32. And so that's where our 0.0625 is coming from. Now, you could go in a layer and say, well, what if we're at 4/5, so 4 out of 5 successes, or 1 out of 5 successes, equidistant from the middle? Well, let's travel back over here real quick and take a look at our dots. The p-value is as extreme or more extreme. So it's these 5 plus that one, and then these 5 plus that one. Okay, so that's a total of 12 out of 32. Now, we're going to be focused on this 0.0625 because that was our original problem. Okay. Now, let me just remind you that your alpha plus your confidence level has to add to 1. So if we're talking about the 95% confidence interval, 95% of what we're dealing with is a distance when we talk about confidence levels. But you can start to think about it from the perspective of, well, if 95% is in the middle, then 5% is shared in the two tails. So this spot from here out is 0.025, and this spot from here out is 0.025. Well, it works out that our p-value of 0.0625, because it's a two-tailed test, gets split in half, so it's 0.03125. And over here would get a 0.03125. That's just 0.0625 divided in half. Well, this value is slightly larger than this value. So this is where our test statistic is actually landing relative to our alpha. If you start to talk about how, well, you know, you've got these levels of significance, wrong phraseology. So these strength of your result, like do you have moderate, or do you have strong, or do you have very strong? We kind of need to talk about that a little differently when we start talking about confidence intervals, because a confidence interval and an alpha have this direct connection. And so when your alpha is 0.05, you think about it more this way. If you're out in the tail, it's a reject the null. If you're in the middle, you fail to reject the null. And you're looking at it more cut and dry, not in terms of like 3 layers. So that being said, if our alpha is 0.025 and our p-value is 0.03125, our test statistic, our p-hat, is here, because that is larger than that. So the p-value is larger than your alpha, so your test statistic is closer to the middle. So based on our p-value, we are going to be, and we compare our p-value to our alpha. If your p-value is larger than your alpha, if you sum those in total, you're going to get 0.06. If you sum those in total, you're going to get 0.05. And p-value larger means you are failing to reject the null. Okay, now, keeping just the 0.03125, if you compare the right side, larger, and then that. So again, failing to reject the null. Now let's travel over here and let's just ask this question. 95% confidence interval, or answer that question, sorry. 95% confidence interval will have half of the confidence interval to the left of the p-hat, and half of 95% is 0.475. So if the p-value of p-hat, and again on one side, is 0.03125, and we add in 0.475, we get a total of 0.50625. Well, that's slightly more than 50% of the area under the curve. So yes, the confidence interval will contain the middle, or the pi. And so just briefly, I'll come over here and I will smudge up my drawing as best as I can. So here sits my p-hat. I have my 0.0325 up to this point, and what I do is I think about, well, here's 0.475, here's 0.475. I'm taking this value and I'm adding it to this value, and that's how I'm slightly past the pi in the middle. Now, the confidence interval is saying that the middle is covered by our confidence interval. And remember, if your confidence interval covers the middle, it's supporting the null. So in this instance, our null of 0.5 is supported. And remember, when we did our hypothesis test based on our p-value, we failed to reject the null, which is telling us the same thing. All right, hopefully this helps.